my God, this is going to be so much fun. You guys are learning the substitution rule today, and we're not using the regular notes. I apologize. They are on the crashed computer. Yes. Thank you, COVID. All right, so we're going to talk about a couple of things here. Nope, not with that. Not with that. Okay, we're going to talk about a couple of things here. Let's just remind ourselves where we were. If you need to take the derivative of something like this, of x cubed plus 2x squared plus 5 to the power of 4. Remember what you do. First thing is you would take that 4 and you would bring it down. And then you would leave the x cubed plus 2x squared plus 5 alone. Then you would reduce the power by 1. And then you would multiply by the derivative of the inside. Okay. Let's also do a problem like this. Let's say you had the secant squared, no, let's not do this squared, of 3x squared plus 2. We need to take the derivative of that. Okay, so the derivative of the secant is the secant tangent. And remember that we leave that argument alone. And so that argument goes along for the ride. And then the last thing we do is we multiply by the derivative of the argument. And that's going to give me 6x. Okay. All right, so now, what if you started off with these answers as integrals? Would you be able to recognize that the integral of this piece would be equal to, not that, would be equal to this? Okay, so if you started off with a big kahuna integral like that, would you realize that the answer would give you that? Well, that's hopefully what we're trying to do with using the substitution rule. All right, so keep in mind what the chain rule is for derivatives. Okay, so if I took the derivative of f of g of x, remember that I would have f prime, and I leave the g of x alone, and then I would multiply by the derivative of the inside. Okay. So then let's look at the antiderivative. Where now, let's just take the integral of this whole chunk of stuff. Oops, not that. I don't know why I did that. So I'm just taking the integral of both sides. And remember that the integral is the opposite of the derivative, which is why we also call the integral the antiderivative. So when I do this, so the integral of the derivative, these are going to cancel each other out. And I'm going to be left with that integral with a constant there. And then over here, I'm going to have this integral of this chain rule. And then what I'm going to do is I'm going to write these separately, okay? So if I want to find this using the chain rule, we're going to let u equal that chunk of stuff inside. So then that means that the integral of f prime of u du is going to give me the f of u plus c. All right, well, let's get rid of the abstract stuff. Let's start looking at actual examples. So find the integral. Okay, so find the integral. Okay, so again, remember, we're trying to find the derivative of what gives me this piece right here. Now, before this section, I would maybe have to take this power of 4. I would take this binomial to the 4th power, and then I would distribute out the x, and then I would take the antiderivative. But now, no, I can't do it. So what I need to do is figure out, okay, what's my u substitution going to be? All right, so with substitution, typically what we do is you pick u to be the inside of something, okay? Often, let's have u be it's either the inside of the parentheses, or it's the denominator, or it's the radicand, okay? But it's typically the inside, the denominator, the radicand, the argument. Okay. So if I said, okay, how about u is x squared plus 2? So that means that du, if I take the derivative of this, and I'm taking the derivative with respect to x, is going to be 2x plus 2, well, 2x and then plus 2 gets to 0. So this would be 2x. So the derivative of u with respect to x would be 2x. And then I want to solve this for du. So just think of this as 2x dx. And then now what I want to do is I want to look at my original problem and see what I have. Do I have these things? Okay, so x squared plus 2, I've got that right here. Now my du, I don't have a 2, but I do have an x. I got an x right there. And I've got a dx. I've got a dx right there. So this piece is almost what I need for my du. So what I'm going to do is I'm going to do some I'll do some math smoke and mirrors so I can turn it into my du. All right, so I've got my x squared plus 2 to the 4th power. And I always put little brackets in here, and the brackets are what I use to represent my du pieces. Okay, so my x dx is what I need for my du. And then I need a 2. Well, I can't put a 2 in here unless I compensate for a 1/2 outside. So that's what I'm going to do. And once I've done that, this has become u to the 4 du. Okay, because this is my u. This whole thing right here is my du. And this is this little 1/2 math smoke and mirrors I needed to compensate. And I can only compensate for numbers. I can't compensate for missing variables. Okay, values and numbers only. Well, now you know how to take the integral of u to the 4th, right? You know how to take the integral of u to the 4th. That becomes u to the 5th over 5 plus c. All right, so that's kind of my answer. It's not quite my answer because what do I have to do yet? Yeah, I have to plug back in my u stuff. So my answer was 1/2 times u to the 5th over 5 plus c, which by the way simplifies into u to the 5th over 10 plus c. But I need to give this answer with x's. So I need to substitute that back in. So this is going to become u is x squared plus 2 to the 5th power over 10 plus c. And that's my answer. All right. So we're going to do this a couple of times, but let's just kind of look at basically what we did, okay? So first, you're going to pick u, okay? You're going to pick u. Use your u choices based off of what the integral is giving you. So you're going to pick u, and then just like I did before, I'm going to find du. Okay? Then we are going to rearrange. Okay? We're going to rearrange our integral. Okay? Rearrange our pieces. We're going to get the u and the du together. Okay? And you'll have basically, in other words, you've got some function of u and then your du. Move those in there. And compensate for missing constants. Okay? Compensate for missing constants. That means you can only compensate for a missing 4 or a pi or an e, but you can't compensate for a missing variable. Okay? Third, you're going to rewrite your integral in terms of u and du. And then you're going to integrate. And then your last step is you're going to do your back substitution. Okay? You're going to do your back substitution. Get it back term into x's or t's or whatever the original variable was. All right. We're going to do a ton of examples and follow along with me. And let's see how that goes. This goes. Okay, so let's look at the next example. Example 2. Find the integral. All right, so I've got x cubed 1 minus x to the power 4 to the 5th power dx. And let's go ahead and take the integral. So again, if we were using past section methods, I would look at this and I would say, okay, I'd have to take this binomial, put it to the 5th power, and then distribute out this x cubed, and then I could take the integral. And I don't want to do that. So what I'm going to do is I'm going to use u substitution. All right, so what if I let u be... Now think about this. I basically have, two things to be u. If I think about, I've got a factor here and a factor here. I have 2 chunks to be u. Remember what I said? You typically want u to be the inside. Yeah, so let's make u be the inside. So it's going to be 1 minus x to the 4. Then let's find our du pieces. So our du, and you can think of it as the du dx, and then whatever your du is has the dx at the end of it. Okay? Or you can just write the du, take the derivative, and stick the dx on the end. It's up to you. But you're basically taking your u substitution and taking the derivative of it. So derivative of 1 is 0. The derivative of negative x to the 4 is going to be negative 4x cubed. So this one becomes negative 4x cubed dx. Now what I do is I look at my original integral. And I look to see, because this is how you know if you've chosen a good u, is if all of your pieces of du are in your original problem. So here's my du. Now first of all, the dx. Yeah, I got that. Next, x cubed. Ooh, I've got that too, and that's important. Okay, well, I don't have the negative 4, but that's all right. We can compensate for that. Okay, we can compensate for that, right? I can always compensate for a value, but I can't compensate for a variable. So I have my x cubed dx, and I'm just rewriting them. I always stick my du in a little set of brackets there. And then inside my du, I need a -4. I need a -4. And so I compensate for that by multiplying by the reciprocal of -4, which is -1/4. And then what I have here is going to be, now I'm going to rewrite it with you. So the -1/4 in the front, that goes along for the ride. Here I've got my integral. And this is going to be u to the 5th, u to the 5th. And then here, this is my du, right? This whole thing here is my du. This piece right here, this is my u to the 5th. So now I've turned this complicated integral into an easier integral for me to manipulate. So -1/4 e to the 5 du. All right, let's do that integral. So -1/4 goes along for the ride. I'm going to have u to the 6th over 6 plus c. If I simplify that, I'm going to have negative u to the 6th over 24 plus c. And then remember what my last step is this is my u substitution answer, but I want to give my x substitution answer. So u to the power of 6, here's u again. So this would be negative to the power of 6 is going to be the 1 minus x to the 4. And then this is all over 24 plus c. And that's my answer. All right, I didn't mention this one, but take a look at this guy. Okay, so taking a look at this guy right here, and we want to find the integral of x times e to the x squared dx. Well, what would be a good u value? Think about it. What would be a good u value? Maybe you came up with this. And I hope you did. Yeah, let's try it to be the exponent of e. So if u equals x squared, then my du is going to be 2x dx. And remember that du, I can think of as derivative of u with respect to x is 2x, and then multiply both sides by dx to get this piece. All right, now let's see. Do I have all those pieces I need? So my u here is x squared. So here I've got my e to the u. That looks good. And this is these du pieces that are the most important. Of course, I have the dx that always starts out. Do I have the variable I need? And I do. This becomes part of my du. I'm missing the 2, but that's all right. We know how to compensate for that, don't we? And I'm up at the top of the screen there. Sorry, it's not totally working. So here I've got my e to the x squared, and I'm going to move this x piece into my du cage, into my parentheses. So here I've got my x and my dx, but I'm missing my 2. So I need that 2 in there, and I'm going to compensate for the 2. So I've got 2, and on the outside I'm going to have 1/2. Right, so there's my successful u substitution. This right here, this one's going to be e to the u. And this whole piece right here, this is my entire du that I need. So I'm going to rewrite it. So this integral is like saying 1/2 the integral of e to the u times du. Well, we know how to integrate e to the u. The integral of e to the u, remember the 1/2 goes along for the ride, is just going to be e to the u plus c. And I don't have to do any simplification for that. Now I can do the back substitution. So here I've got my 1/2, and then it's e to the u, where u is x squared. All right, let's try another. Do 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 ba 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 da ba 3x squared plus 4 dx. All right, team. So this one here is going to be a different type of problem. Remember, again, you're just trying to figure out what the u is and what your du pieces are, and move everything around. All right, so for this one, let's let u be the inside. Okay, so let's let u be the inside, the 3x squared plus 4. So that means my du is going to be the derivative of this. So this is going to give me 6x. And then don't forget the dx on the end. All right, so now once you found your u and once you found your du, remember what we're going to do is make sure that all of my pieces are represented for my du. Okay, your du tells you if it's a good u. All right, so dx, check. X, check. 6, nope, but I can compensate for that, right? So I'm going to write this as the 1/2 power. I'm going to create my du bracket here. I'm going to move my x and my dx into my du bracket, and then I need a 6 here. So I'm going to compensate for 1/6. Remember, I can't compensate for missing variables. If a variable is missing, you need to pick a different u. Okay, so now I'm going to rewrite this in terms of u. So the 1/6 goes along for the ride. If I look at it, this u right here, this is u to the 1/2 times du. So I'm going to have u to the 1/2 du. Again, we know how to find that integral. Okay, this 1/6 is going to go along for the ride. I've got u to the 1/2. I'm going to add 2/2 to that. So that's going to give me 3/2 and then divided by 3/2 plus c. And then let's simplify that. So my 1/6 goes along for the ride. I'm going to multiply by the reciprocal. Since I'm dividing by 3/2, I'm multiplying by 2/3. And then I've got this u to the 3/2 plus c. I'm going to cancel some stuff. My 2 and my 6 will cancel. And I'm going to have u to the 3/2 divided by 9, and then plus c. All right, that's as simplified as I can get it. And now I'm going to put it as my x terms. So I'm going to put my x terms back. So u is 3x squared plus 4. And we're going to put that to the 3/2 power, divide that by 9, and add it to c. Excellent. Let's look at this one. All right, so think about this. What should u be? Typically, you want u to be the inside, the argument, the denominator, the exponent. Yeah, so in this case, let's do the denominator, x squared plus 1. All right, so let's look at du. So the du needs to be 2x dx. Then we just need to look at this. Do we have all the pieces? Well, I have the dx and I have the x. The only thing I'm missing is the 2. So, all right, let's go ahead and write that. So I've got x squared plus 1 on the bottom. On the top, I'm going to put my du. So I've got my x and my dx. Now don't forget, I need to compensate. I need to have a 2 in here, so this is going to be a 1/2. All right, so now I'm going to rewrite it using my u pieces. So this piece up here, this is du. This piece down here, that's u. All right. What do you take the derivative of that gives you the derivative of the argument divided by the argument? Yeah, the natural log. Okay, the natural log of u, the derivative of that is always du over u. So this is going to be the natural log of whatever the argument is plus c. Okay, so let's go ahead and substitute in. Now, x squared plus 1 is always positive, so I don't need to worry about putting it inside the absolute values. And absolute values for the natural log is just because, remember, the inside of the natural log can't ever be negative. It's a big time no-no. So you're going to take the natural log, and let's apply that 1/2 power. That would be the square root. And that's going to be your integral. So the next thing I'm going to do is I'm going to put up a couple of problems, and I want you to see if you can figure out what the u is going to be. Yeah, so see if you can figure out what is the u going to be, and then look at your pieces to see if you have the du. Okay, so bear with me. I'm just going to write down a bunch of problems and then see if you can figure it out. Okay, so for this one, what we're going to do is we're going to look at each of these. I want you to identify what would a good u be. Okay, what would a good u be? And remember, we typically let u be the inside. Okay, we typically let u be the inside of something. All right, now, number 6, deceptively tricky. So we're going to come back to that one. Okay. I don't want you to freak out, but I did kind of want to put the harder one first. But you'll see. Let's warm up on the others. Okay, so go ahead and pause and take a moment for each problem to identify the u and then to find your du. And remember, the du is followed by the dx. And then verify if you have all the pieces that you need. Okay. All right, go ahead and pause and go ahead and do that. Come back when you're done. Okay, for this first one here, did you choose u to be the inside of the radical? Good, because if you did, you would see that you get 2 plus 2x, and then that's dx. And then if you look at that du, and because you may look at this and you may think, oh no, I don't have the pieces I need because you have an x plus 1. But what if I factor a 2 out of here and then write this as x plus 1 instead of 1 plus x? Do I have all the pieces I need? Yeah, I totally do. So that I can think of this as this piece goes to the du, this piece goes to the du. This piece here becomes u to the 1/2, right? And then I've got 1/2 du. So I am missing the du. I've got something that I'm missing, so I'm going to compensate for that, right? Okay. So remember, I've got this 2x plus x squared to the 1/2 power. And in here, I need that x plus 1 dx. But what am I missing? Yeah, I'm missing this 2. So I'm going to have a 1/2 outside of here. Okay, then I go ahead and integrate from there. Okay, for the rest of them, we're not going to explain them that much. We're just going to pick the u's. Okay, for this one, yeah, let's pick the u to be e to the x. So then that means that du is e to the x dx. So this one here becomes the cosine of u. And then these pieces go to the du. So this would be the cosine of your u times your du of e to the x dx. No need to compensate there for anything. All right, let's look at the next one. Now this one's a little bit funky, but again, choose the denominator in this guy. So I've got 1 minus e to the u. So my du here would be a negative e to the u du. And if I look at my pieces, I have those things to use for it. Oh, ick. Notice that I'm using a u substitution and a u integral, so I'm just going to call this w and dw. And if I rewrite this, this is to the power of 2 in the denominator, so this would be like 1 minus e to the u to the negative 2 times my du, or my dw, which is going to be e to the u du. But notice I'm missing a negative. Don't have a negative I can take from any of my original pieces. So I'm going to put a negative in there and compensate with a negative out here. And then I'm just going to take the integral of u to the negative 2, that negative outside. So keep in mind, when I multiply by these things, they get absorbed by the du, but the compensation stays outside the integral sign. So the inside over here, or the denominator, or the exponent. Yeah, let's use the denominator. So I've got z cubed plus 1. I'm going to use that for u. Get a different color here. I'm overlapping. Okay, so u is going to equal z cubed plus 1. So du is going to be 3z squared. And then don't forget the dz. And then look to see what I have. Okay, the dz is there. Yes. How about the z squared? It is. Remember, you need those variables. You can't compensate for a variable, a missing variable. But I don't have the 3. So I'm going to need to put the 3 in and compensate with the 1/3. So in other words, I would have this 1/3. And then here I've got this du over u. And then I would integrate that with the 1/3 going along for the ride. Okay, this one here, use the inside of the sine function for your u substitution. So u is going to be 1 plus x to the 3/2. So du, remember the dx goes along for the ride, is going to be 3/2 x to the negative, not negative, so 3/2 minus 2/2, yeah, so 1/2. So if I look at this, I have the x to the 1/2, right? Here's my x to the 1/2, and I have my dx. So when I rewrite this, I've got the sine of my 1 plus x to the 3/2, and then my du. I don't have my 3/2. That part is missing, so I'm going to compensate by multiplying by the reciprocal out here of 2/3. And then I've got my x to the 1/2 dx. And then I just integrate from there, dot, dot, dot. All right, so let's come back to this pesky little number 6. And this one has a lot of pieces in it, okay? Now, if we just go by the standard, have u be the inside, that's not going to do a whole lot because I just end up with 4 dx. So that's just not going to be enough. So I have to figure out something else. Now, if I look at these things, here I've got tangent of 4x to the power of 3 and secant squared to the 4x. Well, notice that the secant squared is the derivative of the tangent. So what if I just let u be the tangent of 4x? So that means that du would be the secant squared of 4x times 4 dx. So this goes to my du, this goes to my du, and then this would be my u cubed. So this thing here, think of this as my, I'm going to write it with parentheses, my u cubed, and then here's my du. These are all the pieces I have. Notice I don't have that 4, but I can compensate for a 4. And then I go ahead and take the integral from there. Okay. If you have definite integrals, make sure that you do the fundamental theorem of calculus part 2 by plugging those values in. And make sure you can evaluate it. For the definite integrals, these limits of integration are for x is equal to 0. So when you do the u substitution, you can't do anything with it until you get it back into x form. So for this one right here, this is actually going to be in form of my du over u. Okay, but this is x. And this is going to be my du over u because this is my e to the x plus 1 times dx if my u is e to the x plus x. So this is going to be my du over u. And when I take the integral of that, I get the natural log of the absolute value of u. I'm going to weight that for x goes from 0 to 1. Now, when I plug the x back in, I would have natural log of the absolute value of e to the x plus x. Then I can plug in the 0 and the 1, dot, dot, dot. All right? So I would have the natural log of e to the 1 plus 1, the absolute value of e to the 1 plus 1, minus the natural log of e to the 0 plus 0, which is the natural log of 1, absolute value of 1, which is 0. So this would just give me the natural log of absolute value of e plus 1, which is positive. So I can just write it like this. Okay. All right, I hope that was helpful. Good luck with 5.5.